Just
this one.
No.
Okay. Okay.
Microphone is on.
Okay. So very good afternoon to all of you, and thank you so much, Olga, for inviting me to your shoot. And I'm really grateful and very thankful to you for this kind invitation and allowing me to talk to your students here. So I'm Veeky Baths, and I'm heading the Cognitive Neuroscience Lab at BITS Pilani, KKBila, Goa campus, and I'm also a joint partner for iBRAIN project, and Olga is also a partner in iBRAIN project. So before talking, so today I'll be talking about multimodal framework and fusion of EEG, graph theory, and sentiment analysis for the prediction and interpretation of consumer decision. So you are aware of, if people buy something, why they buy something. Is there a buy button on the brain, or if they are behaving in a particular way, why they are behaving in a particular way, or it's what is the their marketing behavior. So that I'll talk about after some time. Before that, I'll quickly tell you what all things we do in our Cognitive Neuroscience Lab at BITS Pilani Goa campus. So our Cognitive Neuroscience Lab is currently involved in three important areas. The first one is on brain-computer interface, and you are aware that brain-computer interface is a technology which completely bypasses the brain's normal output pathway of peripheral nerves and muscles. And it is the only technology by which patients like ALS or serious spinal cord injury patient, they can interact and communicate with their home environment. And we are using SSBP based technology, or SSBP based brain computer interface technology. The reason is because this technology gives you high information transfer rate and high signal to noise ratio. The second project is on Dementia Care, and we use deep learning methods to detect dementia from spontaneous speech. So in dementia, it's not only the memory which gets disrupted, the linguistic skills also get disrupted. So we get conversational transcript or the clinical recordings of those data, and we use deep learning methods to detect dementia. And it's a method which can be useful. And the third one is on consumer. This is something which we already told you about BCI and home automation using EEG signals in 2014. And now coming to the consumer neuroscience approach. Okay, so this is something which I think the people at HSC Moscow, they are also interested in, and all over the world people are thinking that why people behave in a particular way, and is there a buy button on the brain? If there are buy buttons, is there a like button or is there a dislike button? So if it is a like, why they are liking it? Is there a neural correlates for that? And if they are disliking it, why they are disliking it? Is there a neural correlate for that? So I'll tell you why it is important. Now, during the pandemic, you have seen that the digital adoption, the people are more on the digital platform. You don't want to go out and buy something from the physical store. Okay, everything is getting digital now. And now the marketers, we especially will call it digital marketers, they are more using analytics and data science to to engage and involve their consumers. So I want to tell you that marketers or the conventional marketing methodology, they rely on what? Let's say a marketer is selling some product and they want to know how this product is doing in the market, or what is the perception about this product in the market, and how people perceive about my product or service. Okay, so what they do, they will target the focus group. They'll call the focus group and they'll ask that, hey, how do you like, whether you are liking our product? What is your experience? Can you share your experience or perception about our products and services? That is one focus group they can target. The second one, they can send questionnaire. They'll send questionnaire and they'll ask, do you like our product? Whether you have a positive experience. So they share the data. Then they can call one-to people in person, and they'll have one-to-one interactions, and they'll ask that whether you like our product, or talking to, do you like our product or not. Third one, they're calling you in person and talking to you and asking you whether you like our product or not. All these methods are fine, but these methods are not that robust. People might like your product, but they might fail. They will tell, okay, no, we don't like it, but actually they're liking it. So here is the neuroscience approach. Okay, so the neuroscience use imaging. Reason, there are two important reasons. The first one is about articulation. Okay, so consumers, the first one is about articulation. So consumers, they might not be very articulate to express their true preferences. The second reason why marketers are excited about neuroimaging and neuroscience is that they strongly believe that this methodology will provide them an innovative tool which can be implemented even before the product exists in the market. Okay, so this is what they think, that if you put things and get the neural correlates, you cannot fake. While asking or giving questionnaires or to use neuroimaging, it becomes very difficult to fake. So we do lots of machine learning to classify and predict the stimulus using consumer feedback, and do the signal analysis to identify brain activity. There were 94 images, 29 participants, and we did the ERP analysis for like and observed for dislike. You can do the distinction between liking a product logo and disliking a product logo, and this we did it for the ERP. We also do lots of brain topographic studies, and in this study, in the parietal region, when product is disliked, and products that are disliked lead to activation with memory. In this particular study, then we do lots of graph theory analysis. Okay, and it's also higher order interactions and coordinated interactions can be modeled in the form of a brain connectivity graph. In short, it is called BCT. So advanced graph measures like centrality, clustering coefficient are then used to classify and predict different categories in the cognitive processes. So what we have done here is, we have shown the advertisement, and we did the fMRI analysis, and finally we have constructed the brain connectivity graph. Okay, and then we have done the emotional rating, and we have extracted graph measures to create the feature set and use regression models to predict advertising response. So I don't know how many of you know about this graph and graph models and graphs and networks. Graph theory, it's a branch of mathematical science, or it's a branch of discrete mathematical science, which involves vertex and edges, or you can say nodes or links. So you can see the brain topographic structure. There are different regions of the brain. Those regions can be represented as a node or vertex, and any connection between one region to other region of the brain is your link or edge. Okay, And you can see in the red graphs. And the beauty of this conversion, when you convert neuroimaging data into graphs and networks, then it becomes amenable to different kinds of mathematical analysis. Okay, so you see the language is almost, it's very complex, right? 100 billion plus neurons and then lots of synaptic connections. It's already complex. But when you convert those neuroimaging data, like, you have fMRI data, EEG data can be converted, and we can make graphs like that. You can see it on this slide. The red dots, these are all vertex, and any connection between two red dots is your link or edge, and it becomes a graph. Okay, and the beauty of this conversion is that it is amenable to different kinds of mathematical analysis. You can construct urgency list, urgency matrix, cycle matrix, path matrix, and it will give you a better understanding about brain behavior, the structure, the functional relationships. So you can study this behavior. And it's not only you can do it for consumer neuroscience study, you can do for Alzheimer also. Like you have a fMRI data for Alzheimer patient, and you can do the comparisons between mild cognitive impairment or full-fledged dementia. So the network topological structure will be different in people who are suffering from dementia than the normal control subject. Okay, so this is something which is very, very important in understanding brain structure and function relationship. So we are also using predicting emotional response using EEG and machine learning. So you can see that we have shown 8 commercial ads to the subjects, and then we did the EEG pre-processing, feature extraction, then correlation-based subset selection. And TV advertisement emotion prediction using EEG signals. What we got, the EEG from central brain region is critical to classify emotion, and correlation-based feature set performs better than existing feature extraction methods. Now, this is where some which I thought I'll talk about on sentiment analysis. So consumer sentiment analysis using natural language processing. I don't know how many of you know about NLP. It's a buzzword everywhere. Artificial intelligence, it comes under the field of artificial intelligence. Okay, so NLP is a branch of artificial intelligence or AI, giving computer the ability to understand text and spoken words in much the same way human beings can do. Okay, so you know that social media nowadays, they are a war zone. Everybody wants to grab people's attention or the consumer's attention. Okay, and every day tons of data being generated on the social media, right? So you have Twitter, microblogging sites like Twitter, you have Facebook, you have LinkedIn, lots of review forums, you have Reddit, right? You have Quora. So if you try to see, like, every day tons of data being generated, and you do online marketing, right? Everybody does online marketing, like on Amazon, or you have different Walmart portals, right? You go digital and you do what? You do lots of online marketing. And then finally, you want to share your thoughts and your experience about the product. You write something on the review forum. Hey, the product was not that great. Hey, the battery of that computer was not that great. So these are all some of the negative emotions you're talking about, right? So you write lots of stuffs on the social media platform, right? You write it, and then it's a data on the public domain. We can extract those data using powerful Python APIs, right? I can extract the information, and your opinion is a big thing for marketers. Okay, based on your opinion, all text information I can extract from the social media platform, and then I can use my NLP and CNN LSTM technology to classify your textual information. Whatever you have written on Facebook, or whatever you have written on review forums, or whatever you have written on Twitter, all those information, tons of information I can extract, use an NLP and CNN LSTM, and classify those information into positive emotions, negative emotions, and neutral. And when I talk about emotions, there are cognition involved, there is a cognitive neuroscience perspective. Okay, so understanding consumer through only neuroimaging or eye tracking is not sufficient. You have to see their opinion also, which is available on the public platform like Twitter or review forums. So I extract all those information, use CNN LSTM, and classify them into positive, negative, and neutral emotions. And finally, I did this study for Indian paying apps. There are payment apps, right? So we have done for Amazon Pay, Axis Bank apps, and Paytm in India. Okay. So what we did the sentiment analysis. This is a computational task of automatically determining what feelings writer expresses in text and classify them as positive, negative, or neutral. Okay. And then we did the data processing. So we did the reviews of 3 popular UPIs apps in India, where it was collected from the Google Play Store. And we took total number of 10,800 reviews. Okay. We took 10,800 reviews and we did the data grouping. So -0, neutral 1, and +2. And then we use the BERT, which is called bidirectional encoder representations from transformers, proposed by Google Research in 2018. And then you can see the model parameters. The batch size was 16. Then training done using Adam 2, and total number of epoch were 10. So this is the result we got on the test set. The model predicts positive reviews with an accuracy of 65% and negative reviews with an accuracy of 68%. But the accuracy on the identification of neutral review only 50%. So you see the accuracy we are getting 65%, and then for positive reviews, and for negative it is 68%, right? How we can improve that? So that is the question, where it's not only doing sentiment analysis or natural language processing will help. So what we are proposing and trying to develop a multimodal scheme where you fuse the neuroimaging data of, like, let's say EEG with this sentiment score data. And when you are doing that, then it will give you a robust multimodal scheme to understand consumer behavior, their perception. If they like it, why they are liking it? Is there a like button on the brain or not? So you will get what? You will get a multimodal scheme to understand consumer behavior or their emotions. So it's a positive emotions or it's a negative emotions, stuff like that. So the take home message is what? Human emotion is very complex. Okay. And sentiment analysis is a method of analyzing consumer emotions from their review data. And this type of analysis heavily relies on the writing skills of consumers. So I can say, it's not that easy to always understand what is written on the social media platform or the review forum. I can write, "Thank you so much for the product." You might think it's a positive emotions, but it might not be positive emotions, because people might sarcastically write it. "Thank you so much for the product." They can sarcastically, they can write about this, right? So it's not that easy always. So that's why fusion of EEG data with the sentiment analysis data is the need of the hour, where you'll help or you'll get the multimodal scheme to understand consumer perception, consumer behavior, and consumers' emotion. And also this type of analysis heavily relies on the writing skills of consumers. So people, they write something on social media or review forum. It's not always grammatically correct. They write very, in an unorganized way. It's not properly structured, right? So it's very difficult to understand what people write on Twitter sometimes, okay? Because sometimes it's grammatically not correct, right? You might think just like that, and it's not very structured, ordered. So these are the challenges for doing natural language processing, right? So the need of the hour is to fuse this sentiment analysis of consumer with the EEG data, where you are bringing on the cognitive neuroscience perspective. Okay, everybody, like, all tech giants like Google. You think Google is free? How many of you understand Google is free? Google is free? Yes? No, you are using it for free, right? Google knows in and out about you, okay? Based on your search history, based on your browsing history. And Google saves every data. Google saves every data of yours, okay? And then they do your psychological profiling. They do your psychological profiling. And after doing psychological profiling, behave in a particular way. Okay. So the need of the hour is to develop a multimodal framework for critical signals and product reviews to provide data and sentiment analysis data. And then it will give you the multimodal framework for predicting consumer perception, and it will give you improved sentiment score. You can know about the true emotion and perception of people or the consumer if you are fusing neuroimaging data with the sentiment analysis data. So what are the benefits of having this multimodal framework? Integration of consumer metrics from EEG signals with consumer sentiment score. It generates comprehensive and offset each other's drawbacks, okay, and customize the product and services. So that is a sentiment score. So with this, I'm done with this. And if you want any query, if you have any query, please, feel free to ask me questions. I'll be very happy to answer your queries. Okay. And these are some of the, not some of the, this is our iBRAIN collaboration. And this is literacy and cognition project we have with Max Planck Institute for Psycholinguistic research topic, Vakvoetic from Max Planck Institute for Psycholinguistic in Nijmegen, Netherlands. And we are also working on binocular rivalry and comparison of visual perception between meditators and it might not work in India, right? So the cultural aspects or cognition aspect is also taken into consideration while making decisions like this. So this is also very, very important. And these are the recent publications. So by the way, I have not published most of the data because consumer science, I'm consulting on industry where we have a non-disclosure agreement. So this agreement is coming to close by then we'll publish lots of things on consumer neuroscience. So the fourth paper, you can see reinforcement learning is also being used in consumer neuroscience. And this paper, I think Boris also gave his input in this. So Boris is also our partner in iBRAIN project.
Boris Gutkin.
Yeah?
Just Boris Gutkin, I just clarify for everybody.
Yeah. So that's what we do. And thank you so much. If you have any query, you can ask me. I'll be very happy to answer your questions, and write to us if you need any help or suggestion or any insights related to cognitive neuroscience and consumer neuroscience. So thank you so much for your time and attention. Thank you so much.
Thank you for your lecture. We have a question already.
Yeah, thanks a lot for a lecture. I'm a PhD student here, so my question will be, well, I understand how marketing can benefit from your research, but I would be more interested to know how you interpret your data from ERP analysis, for example, why those particular components are diminished or increased. I don't remember which one, but yeah, this is the first question. And
so what is this exactly? What is the specific question?
Well, how do you interpret
ERP?
Interpret, yeah, ERP analysis? Why P2 is, if I remember correctly, was
like and dislike.
Yeah, in those two conditions.
Yeah, like fundamental mechanisms
of
this process.
In general, what can this tell us about like brain? And also the second question will be about if we combine these two approaches of yours, like graph theory and NLP analysis, well, is the data from these two approaches consistent or not? Like, because you told about this general approach, but I'm not sure how, like, well, NLP doesn't tell us a lot about brain. So how do you really combine it?
Yeah, so that's what, like, so for coming to your first ERP. So ERP, it's nothing but it's a time logged EEG only. ERP is nothing but it's time logged EEG. Okay. And ERP is event related potential. It is of two types of ERPs. One is called exogenous CRP, the other one is called endogenous CRP. So exogenous CRP means, so the first, let's say 150 millisecond, you'll see the all external features of the product, right? After that, after let's say 150 millisecond, you give more cognitive load to your brain and you start thinking, okay, what kind of product it is worthy, shall I buy it or shall I not, or what benefit it can give. You start evaluating and assessing the product. So it takes more time. So maybe after 300 millisecond, you will understand about that product. But first 150 millisecond, it's exogenous CRP. It only talks about the external features like the size, shape, color, and all those things. Okay, so it takes only 150. Now, very fast, you will see only the external features, size, type, and all those things. After that, you start evaluating it and doing the assessment, giving more cognitive load to your brain to understand this. So this is how ERP, the time-locked ERP, will help you in understanding and evaluating a product. Okay, number one. Then there are different, waves, like, positive waves or negative, like N200 or P200 or P300, right? So based on that, you can, discriminate between these ERPs. Coming back to your second question, where you are talking about sentiment analysis is not just the brain science, right? Of course, it's not only simply the brain science, but what we are doing from the text, we are trying to extract the emotions. If you write something on review forum, you buy stuffs on online platform, right? You buy it on Amazon, you buy it through Amazon. Have you ever bought anything from Amazon?
I never.
It doesn't work in Russia.
Oh, Amazon doesn't. So, but you have some online platform, right? There you find people write reviews, their experience, right? Like you see the review, right? Before buying, you see the reviews, whether it's a positive review or negative review, right? So I extract those information using, Python, powerful Python tools. I extract those information and I classify them into positive emotions, negative emotions, and neutral. Again, it's there. I'm not getting into the brain. I'm simply analyzing your textual information using NLP, natural language processing. And now what I'm proposing, that very few people have done it, and I'm consulting on industry on this. What I'm proposing, the same thing. If you're buying it online, I put the electrode here, I take your recordings and get the data and fusing this data with the sentiment analysis data. And then I'm trying to give you the robust and reliable way of understanding people behavior or their buying patterns.
But you have to do.
So let's say it's a study where I do, let's say I'll tell this guy to buy something online, and then I will also use their reviews and see how best, you can develop a multimodal scheme to understand the consumer buying patterns. Yeah, thank you.
Okay, thank you very much. We have one question from internet audience. Did you ever think about ethical aspects of developing tools giving companies almost unlimited power over minds of consumers?
Yeah,
rather philosophical.
Yeah, so there is a question of business ethics. People will make you to buy something, right? And they are all, so there is a question of business ethics, but when you want to do business, sometimes ethics is at the back seat, right? Sometimes ethics is at the back seat. We have seen it, but yes, it is an ethical issue, serious ethical issue, because the way they market it, they will make you to buy something which you don't need. You are not, you don't need that, but the way they market it, the way they influence your brain, you are buying it. It's unethical, right? It's unethical. Sometimes, you use your emotional brain. Sometimes you use your rational brain. When you are rational, you know what to do, right? You will evaluate the product, hey, whether it is worthy or not. Shall I buy it or not? You see all pros and cons. You start weighing all your options. Shall I buy it or not? When you use your rational brain, but when you become emotional, you simply buy it, right? And they play with your emotions. They play with your emotions, right? Your mama was buying that. Your mom used to buy that. Okay. And there is a, emotional connect between mom and son or mom and daughter, and you also buy it. So Yes, of course, there is a serious ethical issues associated with this kind of neuromarketing, and then there is a question, because we don't use only one brain. We have two brain. One is emotional brain. Other one is rational brain. Okay, so that is what I can say about that ethical issues. Yeah.
Okay. So do you have another questions? So I guess. Thank you very much. But I see your presentation is more like for how to sell your products. I mean, how to sell your scientific products. We're just fundamental scientists. We just more interested in how brain works,
Right.
not how to sell something to customers. But maybe you can just shortly describe your activities. Maybe you have fundamental research as well in your lab.
Yeah.
Like psycholinguistic at all.
Yes.
So,
we do lots of psycholinguistic stuffs. Yes, and we do lots of brain-computer interface.
yes, it's fundamental. It's not supported
fundamental.
by you. Okay.
Yeah.
Okay. Thank you.
Yeah.
So if you don't have questions, thank you very much for coming. Next meeting will be next Monday. So bye. I think we can